Hello everyone and welcome to this episode of the Sevenfold BIM Academy. This is Tim Halverson, and in this episode we are going to be looking at how to produce this feature wall in Grasshopper. Now you can see it's variable in size as well as texture. We have some controls on how to split this, as well as control how to have the different colors here. And as we go across this, there's a different height that we can control as well. This is a mesh-based solution. So if you're not comfortable working with meshes, this tutorial is for you. And this is going to work for more complex surfaces as well. So for example, we have this one here that is undulating in size. And if I just bake that out, you can kind of start to see what the solution is here. Now, we're going to go into more detail on how to repair different surfaces if some of it doesn't work for you. But this is kind of the solution that we have here. And so, yeah, without further ado, let's go ahead and dive in. Now, some of the prerequisites you're going to need in order to get going with this. A couple things. You're going to need M+ as a plugin. You're also going to need, for a couple things, pufferfish, paneling tools. Paneling tools will be how we get the grid length at the beginning, and then to bake out at the end for our components. And feel free to use whatever bake software you want. I'm going to be using Elefront to do that at the end. Okay, if you are excited about this as much as I am, strap in and we are going to get there shortly. All right. If you don't have those plugins, go ahead, hit pause, run over to foodforrhino.com, download them, get them installed, and we will dive in. Okay, so go ahead and launch up a fresh Rhino session. And if you have a template like I do, I'm going to use an inches template. This is one of my template files. And I'm going to go ahead and just work on the default layer. First thing you want to do is go ahead and work with creating your surface. So I'm going to use a 3-point surface here. And actually, before I do that, I'm going to set my C-plane to vertical. And then I'm going to draw that 3-point rectangle and just let that be my feature wall. Give yourself some context wherever you want. We're just going to go ahead and do a straight wall in this instance. I'm going to launch Grasshopper. And I'm going to put Rhino on the left and Grasshopper on the right. First thing I want to do too is go ahead and do a surface component. Right click, set one surface. And in the paneling tools tab, we want to go ahead and do grid. Surface domain length. I also, just as I like to try to put new surfaces in, I like to create a copy of this, reparameterize that, and then plug it in. So as we create more surfaces later, you can run it all into the same starting point. Plugging that surface into the S, and now we can get the length in both U and V. And the reason we need this is because we can actually type in a specific width and length rather than an arbitrary number. So I'm going to do a slider 6 less than 12 less than 24. It's going to be a range. I'm going to plug that into the U, alt drag copy, plug that into V, and I'm going to change this to something a little bit higher, like 18. Okay. So go ahead and go over to Mesh Plus, go down to Make, and then select the rhombic trihexagonal tiling. That is a mouthful. And you can explore various different tiling options, but I'm going to explain how to set this one up. Plugging your surface into the S, and then what we want to do to get the U and V count, rather than an arbitrary number, we want to get it based off of this grid that we've created here. So in order to do that, we want to get length, So type in length, go to list length, plug that in. If I do a panel by doing quotes, hitting enter, you can see we have 82 along the width. And if I flip matrix, we can see that there is 15 in the vertical direction. I want to go ahead and flatten that down by right-clicking, hit flatten, right-click, flatten. And then I want to create a set. So type create set. Merge those in by holding shift. And then that's going to give me the unique values that are in that set. So 82 and 15. Now I just want to make sure that my shortest direction is always on the top. I'm going to sort these keys, and those keys, I'm going to do item, typing in item, grab the first one, and zooming in, hit plus to give me the 0 index here by default, as well as the +1 index, which is 82. So I'm going to put the first one into U and the second one into V. And I'm taking a look closer. I'm going to hide some of this stuff so I can see it more easily. And then I'm also going to go up to edit and go down to mesh explode. Plugging in my M to here, it's going to help me see. And then I want to do mesh edges, typing in mesh, edges, plugging the A into the M. It's going to give me all of my edges. Now it's a little bit confusing, but it looks like they're going in the wrong direction. So I want to flip my U and V input here. And there we go. So now we've got what we were anticipating in terms of the grid. And if I want to go ahead and change this, feel free to do so by increasing or decreasing the size on your sliders. Okay, so I'm going to go ahead and work with this. And let's keep moving forward. So now that we have our edges, our U and V count defined by a specific dimension in inches, I'm going to start working with the actual edges. Now, each of these is its own cell. So in some cases we have quads, some cases we have triangles. And when I exploded that out, you can see here that there's a branch with individual lines representing the 4 edges. So in order to work with those, I want to work with them together as a single polyline curve. So I want to type J for join curves, plug in my E1, and E1 is going to be your naked edges. The E2 and E3 are different types of edges, but in this case, we have all naked edges. And I'm not going to go too deep into that, but basically we just want the stuff in E1. So now we have polyline curves. These are all closed polyline curves. And what we want to use it with is the offset command. So I'm going to use this offset curve. You can use the vanilla built-in for Grasshopper, but I'm just going to use the pufferfish one. It gives me a few more options. Plugging C in, we can see right away, we can see if we plug into C, a few options. Now, by default, it's actually going out and I want it to go in. So changing the distance, I can right click, go to expression and type -x and commit those changes. That will go ahead and switch it, but you can see in some cases, like right here, this is actually flipping out instead of in. So we want that to be flipping consistently rather than some cases where it's going out, in some cases it's going in. We want it to always be going the same direction. How do we stabilize that? Well, we need to relate our curve back to our original surface. So I want to evaluate surface by typing evaluate surface. And if you're looking for it, it's in the surface tab under analysis. Taking my surface output and my surface input, that is the first step. Now the next step is we need U and V, UV coordinates. And to get that, we're going to go up here, do surface closest point, plug that same surface in. And now the point we need to evaluate it against is something that's specific to my polyline curve. So what I typically do is type in area, which is going to give me not only the area, but the centroid. So plugging that curve in, it's going to give me the centroid here. And now pulling that centroid point to my surface, I'm now going to get the UV coordinates of the point to the surface. Okay, and those UV points are essentially a percentage. Because we reparameterized this way back at the beginning, that's giving me some percentage of 0 to 1 rather than a length dimension. It's actually some percentage. So no matter how big or small this surface becomes, it'll always be some percentage. Okay, plugging that U and V into the UV coordinates. Now I'm able to get this plane, which is this plane here. There's a bunch of different things for that, but the main reason I want it is to input that as the plane I offset from. So plugging that into my PL, you can see right away, if I just undo that and redo that, you can see we're flipping everything to be consistent because we have our plane consistently going with Y up and X to the right. Okay, so now I'm going to hide it because it's a little bit distracting. And I'm going to hide this stuff as well. So there we go. We're starting to get some patterns going on. Now to control how much offset we're actually having, I want to input a slider to this D input. By default, it's 1, but I'm going to make a slider from 0, less than 1, less than, let's just do like 12. And I'm going to do 0.0 to give myself some decimal points. So that gives me a single decimal point by default. Plugging that in, I can reduce that and tighten it up to as little or as much as I want. In this case, I'm feeling very tight. So let's just do like 0.2. All right, getting there. So if this is where I wanted to end and I didn't want to do the complex undulation, I could go ahead, go to M+, make fill mesh holes, plug in my curves to the P, and I've got meshes. I can go ahead and bake that out, and that would be great. But what I want to do is actually create some pattern to give this some more volume. And so in order to do that, we're going to start to play around with that center point that we made earlier and vary the height up and down across this entire surface. So before we get to that, I do want to also show you how to color it in case this is the point you want to leave and you don't care about the volume. So let's go ahead and add some color. So to preview this, I'm going to bring up preview, and I'm also going to create a gradient, typing in gradient. And if you don't want to use the gradient approach, you could just as easily input your own custom images through the image sampler and selecting an image that you maybe customize in Photoshop or find by any other means. This is a great solution as well, but I'm just going to use a gradient as my input. It would be the same workflow. You'd input your points down here. Okay, so I want to first deconstruct my point for these U and V points. So remember, we evaluated this point on the surface throughout the entire surface. So now that gave me a percentage from 0 to 1, both in the U and the V direction. And so now each of these is associated to its geometry. So if I take these UV points and I unpack them or deconstruct them, and then look at my outputs, I'm getting a percentage in the X, a percentage in the Y, and a percentage in the Z. And because this is relative, so this U is essentially the X, the Y is the V. So it's just it's relative coordinates. Okay. And the reason I'm basically, I just want to use the X because this is a linear slider. If you wanted to put these points directly into the image sampler, that would be the solution to putting your image in. But because I'm using a gradient and it's linear and it's not changing up and down, I only want to use the X coordinate to analyze. Okay. All right, so I want to go here. I want to tweak these colors just a little bit. Bear with me. All right. So once you have customized your colors to your heart's content, hit OK. Now we can associate our geometry, which is our meshes, to the M. Okay. And taking a closer look at the preview, you can see that it is all beautiful. Hiding my base surface, you can see just what we are getting. And like I mentioned, because we only use the X, it's matching that linear direction. If I had taken some kind of image, like let's just grab this one, or let's maybe pick a wallpaper or something. Like, let's go with this one here. Why not? Okay, so if we took this image and we really like this image, we could, instead of unpacking the point, plugging in here and then making that preview happen, you can see it's basically applying the colors to the geometry. And so, you know, pretty interesting. Lot of flexibility you can do here. You know, if I wanted to do the beach, I could do the beach and get this mosaic pattern happening, which is really fun. A lot of flexibility here. I'm going to stick with the gradient and just go with that. Okay, cool. So again, once you're ready, you can bake that out and be on your way. But we're going to take it a step further. Okay, so stick with me. So the next step is we're going to start to play around with the normal direction of how high these go. So I want to go to the mesh tab, go to deconstruct mesh. And now we're going to get our vertices, our faces, our colors, and our normal directions. All I really care about in this one is the vertices at this point. So I'm just going to create a point container to hold those. I'm going to hide this just because it's distracting. And what this is giving me is a lot of information. It's giving me all points around the edge as well as the center point again. The first command we want to do is we want to move the center point up and down. Now, we're getting 5 different points. Now, how do we know which point we want? And in the triangles, it's 4 points. But how do we know where the center point is compared to the end points? Well, I'm going to do a test to see which ones are closest to the edge. So if I type in CP for closest point, do curve closest point, take all those points and plug it into P, and then take my original offset curves and put that into C. Now what the output is giving me is a couple things, but I want to use this distance as the test. And you can see it looks like at index number 4, and in some cases towards the bottom we have index number 3, that is the center point because it took the longest to travel to get to it. There's a couple ways to do this, but I'm going to sort this list of points into A. I'm going to sort it by distance for K. So the sorting key is the distance, and that will make sure that no matter what, the most traveled distance will always be at the bottom. Now that I've sorted that, I can go to pufferfish, go to list, grab list indices, as well as the last index. There's a couple things we need here. And so we're going to grab the last index from our sorted list. It's going to tell me, in this case, it's 3. In some cases, it's 4. So I'm going to grab the last index now that we've sorted it. And I'm going to do split list. And we're going to split this list at this index. And in A, it's going to give me these points. And in B, we should have just that last point. Okay, not using dispatch. And so because of how this is set up, I know that this point that traveled the farthest is actually the center point that I want to use to do my manipulations. So that's going to be the point that we move. So plugging that into G and then typing in, we want to get the normal direction. So we've got our normals back here and we want to set the amplitude. So typing in amplitude, the vector is the normal that we want, which is going to go in and out from the surface. And then the amplitude we can also get creative with. So I could do a fixed amount by just typing in a slider, 0 less than 1, less than 12. And that's fine. You can totally do that. I'm going to make it a little bit more dynamic. Okay. So by modulating it, we can do a graph mapper. Graph with a PH, not an F. Thank you very much. And then setting graph types to, let's try sine. You can explore the different options. I'm going to grab this point here, pull it to the left, and we're going to do something like that. Okay. Now, likewise, we're going to use our points here for UV, just like we sampled it on the image. We're going to sample it across this graph here. And then we're going to remap. Whoops. We're going to remap all these points from the source. So the values are going to go into V. The source is 0 to 1 by default. And then we want a new target domain. So going up to maths, construct domain, we want to do, let's just grab a copy from this here, holding Alt, dragging that copy, put that into the lower bound, make another copy with Alt drag, crank that up to like 10, 11, 12, whatever you want. And that's going to be my target domain. And now I've remapped those percentages back to useful dimensions I care about. And plugging that into the amplitude, now we've got a dynamic undulating up and down. And if we want to visualize this quick before we go too much farther, I can just do a line. And I can plug in B to my A input and my moved point into B. And can hide a bunch of this. You can get a quick visualization of what's going on here. A little bit. It's a little confusing right now, but we'll unpack it more soon. But essentially, you can see it's starting to undulate. And I could create a color map or heat map based on how much it's moving up or down, but let's just get to the geometry generation and we'll show you. But so now what we want to do is connect our moved point, our upper point, to, instead of the spoke here, we want to actually connect it to the other edge points. All right, so that's going to create that space frame type shape. The result is we have multiple lines on a single branch, but we want to work with each individual line. So we're going to graph that, type in graphed. And then what we want to do is use the relative item component. And this is one we talked about in a previous video. If you haven't checked it out already, go ahead and check it out. We explain it in detail. But essentially, plugging this grafted list into the T and working with our tree over here. I want to make this a little bit simpler on myself, so I'm actually going to go back upstream. I want to simplify at the offset and then check, and you can see it's getting a little bit more simple down here. We also want to simplify, what else? Let's simplify down here as well. Okay, cool. So now that we've got that, we've got a more simple branch structure. And so that'll help when we type in for the offset, do quotes, open brackets, and then 0, semicolon, 0, semicolon, 0, semicolon, +1, closed brackets. And this is basically aligning to our branch structure. So we're not changing any of these ones, but we are working with the last branch. And that's why we branched it here, so that we can loop it in. So plugging that in, A is going to give me my original line, and B is going to give me my offset line. So if we merge those together by typing in ME for merge, that's going to give me my first two lines. And then the third line we need is, so we have two lines here that are next to each other all the way around. And then we also want to go to wrap paths and set that Boolean to true, because we have a self-contained loop within each space frame. So essentially what that's doing is putting this line with that line, and then that line with this line with that line. And so each of them are grouped together on their own branch. And if we hadn't done that wrapping, it would have missed one of those panels at the end. Okay, so we've got two of them together. We need one more line, which is this baseline down here. So to get that, we want to go back to our join curves and explode those, typing in explode, plugging that curve in and bringing it forward. We've got our segments here. We want to graft each of these as well. And then plugging that in, checking that. Looks like because of how we've managed things, we have the same structure here. Okay, so after a lot of investigation, I found out what the issue was. Instead of plugging in the normal direction from the deconstruct mesh here, instead of doing that and then getting the normal, which is going to give you 4 normals per face, or actually per subface. So these 4 faces inside of the mesh, that's what these 4 are. That was wrong. Instead, going back to when we evaluated the surface here at the center point, we get the normal direction here. And so plugging that normal into my amplitude, that's going to create the undulating vertical offset along the surface face. You can see here we've got starting to come together. There we go. And okay, one more thing. If you don't want these spotty elevations based on the sine wave as your input, you can also deconstruct the point along that. So plugging in my graph output to deconstruct point, and then only taking the X value from that and remapping it is going to give me one direction. And that's going to help control my input here. And likewise, we could reduce this height to be a maximum of something less if we want to, depending on what proportions we want. So in this case, we have a maximum of 6 inches here, a minimum of 1 inch offset, and that's undulating based off of the sine curve here. All right, the final step we need to do is actually get this out. So we need to bake it and put the colors, associate the colors to our geometry. So if you didn't catch the update from before, we offset our curve to create individual meshes, so that in this case for this space frame there's 1, 2, 3 meshes to create the entire panel. In that case there's 4 meshes here to create that panel, and those merge together. We join the curve into a poly curve, closed poly curve, and then we do that same fill mesh holes to create our closed meshes. Finally, we could also do a mesh join mesh, and plugging in these meshes into this input, it's going to create a single mesh per panel. All right, now checking the output, we can see what our layer structures, our tree branch structure is doing. Now we want to match that to the output of our colors. So looking at what we're getting here, we've got a simple structure along with the same type of data here. So I want to do shift match and make this as a guide, and the data here, output from my gradient. All right, so we want to go ahead and do an offset shift paths. We want to shift that by 2. -2. And then we want to input our color data and then use this as a guide. So this gets us back to the amount of data that we had when we input this gradient. So the way we can check that, if we do viewer, looking at the output here, we have 1,221 branches. We also, if we look at this, we actually have 3 times that in many cases, but we actually need to shift that back so we get the same number of branches in both cases. And then we can match the branches there. So by using this as a guide and outputting that, we've got matching branches. And now when we join those meshes together, we have the same number of meshes as colors. And now to get that to bake, we're going to go over to Elefront, go to bake. We need some inputs, the attributes, geometry, and bake button. The geometry is going to be my meshes right here. Attributes, you can get that by defining attributes. We're also going to define a color, and we're going to define a layer to go on. The colors that we're going to define are simply the input RGB values. And that's going to give me Elefront compatible colors. I'm going to place those colors into my attributes right here. And then finally the layer, I'm going to plug into the L input here. And I'm going to give it a name. Let's just do feature wall, colon, double colon, and then we'll just call this like motif number 1. Plugging that into the name, leaving the color empty because we're defining the color on a per object basis down here. Plugging those into the attributes, and we're good to go. And then finally, I'm just going to add a button and call that Bake Me. I'm going to right click, change the wire display to hidden, and then put Bake Me into the output. Finally, I'm going to drag it all the way back to the beginning by my inputs here and bake it. And then I'm going to do Control N, and voila, there we go. We have our feature wall with all of our colors per the gradient with this dynamic undulating form. And it looks beautiful. Now, if you've gotten into Rhino and you want to split that geometry, and maybe you want to do it over a door frame or something like that, all you need to do is define your curve, whatever that, whoops. Let me set this here. Okay, and then I'm going to project. And I'm just going to define a doorway of some kind. Now, if you want to go ahead and split this geometry around that doorway, what you need to do is extrude curve. I'm going to go in both directions. I'm going to Control Shift select these two here, loft those into a surface. I'm going to join those by doing Control J and then typing in cap. I'm going to make it a closed B-rep. Finally, I'm going to select all on my motif that we just made. Go over to the Mesh Tools tab, select Mesh Split, and then select the cutting objects as my new closed B-rep. Finally, I'm going to select my closed B-rep, go to my selection tab. If you don't have it docked here, there's a separate toolbar for select, which is right there. I have mine docked right on the side here. And selecting that, going down to select by closed B-rep volume, that gets me most of my content, most of my geometry that just got cut. I'm going to delete that, and then I'm actually going to make this just a little bit bigger. Just to display it more clearly, I'm going to switch this to a more invisible setting. And then I'm just going to hold shift and scale this just a little bit and repeat that select by closed volume to get those edges and delete. And now I can delete this and I've got my doorway. I realize that's a destructive method, but be sure what you want to do and how you want to define your opening before you start slicing. You can always regenerate your feature wall in Grasshopper and repeat this process, but that at least gives you a way to make your edits. All right, everybody, thanks for sticking with me through this tutorial. I really appreciate you. Go ahead and Subscribe to the Sevenfold Design Technology page if you haven't already. Also, head over to bimacademy.sevenfold.io, sign up for a newsletter, and we're going to keep publishing both free content on the YouTube page, but also more detailed instructions at the BIM Academy. Have a wonderful evening, and we'll talk soon. Bye.